In this video, I'm going to review the difference between random and non-random sampling, and then I'm going to go into the different types of random and the different types of non-random sampling. The difference between random and non-random sampling all comes down to whether all population members have an equal chance of being chosen to be in the study. If all population members have an equal chance of being chosen, it's random. If the population members don't all have an equal chance of being chosen, it's non-random. So if one type of population member is more likely to be contacted to take the survey, and another type of population member is less likely to be contacted, it's non-random, according to this definition. So I mentioned that to give all population members an equal chance of being chosen, you have to do some type of a random lottery or random drawing, like pulling names out of a hat. If you put 100 names into a hat, shake it up, and take out 10 names without looking, then all population members have an equal chance of being chosen. Those 100 are all equally likely to end up being one of the 10 selected people. Well, at least in theory. And if you just walked up to someone, just let's say on the street, and asked them, how would you select people randomly if you were giving out a survey? Well, the person might tell you, I would go to a public location and I would walk up to random people. I would just see who I come across and give them the survey. Well, that actually isn't random. We talk about random in that way in everyday life, but that's actually not random. So that's because if you just went out to a public location and came across random people, random in quotes, and asked them to take the survey, you actually wouldn't be doing it randomly, because you would probably be more likely to walk up to people who are friendly and avoid people who are look less friendly. And if you did that, you wouldn't be giving all population members an equal chance of being chosen, and you probably wouldn't spend an equal amount of time at each area of the location that you're visiting. You might end up spending more time in one area and less time in another. And if you do that, then some people will be more likely to be reached by you and other people less likely to be reached. So it's not random. You're not, even though it seems random, that wouldn't be random. You wouldn't be giving all population members an equal chance of being chosen. It might help if I explain the difference between random and haphazard. So if you just go to a public location and see who you stumble across and see who's there, that's actually haphazard. So the word haphazard means aimless or without direction. So that would be more like of a haphazard sample. I think it might help you understand the difference between random and haphazard if I give a food analogy. So this is actually an analogy I read online somewhere. Imagine you have a bowl of soup in front of you, and you want to take a sample of 1 spoonful. If you stir the soup really well, and then you take the spoon and eat it, you're getting a random sample of the soup, because all pieces of soup in that bowl have an equal chance of ending up in the spoon because you stirred it well. But if you just turn your head and dip the spoon in somewhere and it lands where it lands, that's a haphazard or aimless sample of soup, and it's actually not random. So hopefully that helps you get the idea of what I'm talking about. I think I was actually having a conversation with a student a couple of semesters ago, and I was helping the student answer some question about random sampling, and this question involved a scenario in which a person goes to a college campus, goes to a certain location, like let's say the Union, and the person gives out a survey to whoever happens to be there. And I was asking, is that random or is it not random? And the student was telling me that she thought that it would be random because the researcher doesn't know who's going to be there ahead of time. And it's true that the researcher doesn't know who's going to be there ahead of time, but it's important to remember that those people who actually are there aren't there randomly. If the researcher goes to a certain table at a student union, the people who are there who the researcher surveys chose to be there. They decided to go to that spot and spend their time there. So the researcher actually isn't giving all population members an equal chance of being chosen, and people are not being selected simply by chance. So that's actually not random. I also wanted to mention that to get a random sample, it's not enough to simply give all population members an opportunity to be in the study. If all population members are invited to take the survey, it still might not be random. If some population members are more likely to end up in the sample, it's actually still non-random. So I'll give a simple example of what I mean. So imagine I'm teaching a class, and I write on the whiteboard that I need 5 people to take my survey. And then I stand there and I wait for 5 people, 5 volunteers, to walk up to the front of the room and take my survey. If I did that, everyone in the class has been invited to take my survey. No one has been excluded on purpose, but it's still, the 5 people who end up coming forward and taking my survey aren't going to be a random sample of the class, because some types of people will be more likely to walk up to me, and other people will be more likely to just sit back and not volunteer. The people who are more motivated to take my survey for whatever reason are more likely to walk up to me and take my survey, and people who are just in a good mood that day will be more likely to walk up to the front of the class. So it's not random. So you have to remember that whenever you're giving out a survey as a researcher and you're just waiting for volunteers to come forward, you're not going to get a random sample, because the people who step up to volunteer are going to typically be different than the people who don't bother to volunteer. That's why putting up flyers in a public location, like a university, actually won't give you a random sample. If you went to your university and just put up flyers all across the campus saying, I need participants to take my survey, and let's say everyone at the university, all of the students end up seeing your flyer, which actually probably won't happen, but let's imagine that they all end up seeing it. Even though all people at the university are invited to take your survey, you're not going to get a random sample, because some types of people are more likely to step up and volunteer, and others more likely to not volunteer. And you're going to end up getting more of a certain type of person and less of another type of person. So I just wanted to point that out. Sometimes methods that seem random are actually not truly random. And so what would you do if you actually did wanted to get a random sample of a university? Well, what you could do is get a program, a computer software program, to randomly generate student ID numbers. And you could then contact the students with those ID numbers, and you would get a random sample of the class. I'm sorry, you would get a random sample of the university, because all ID numbers are equally likely to be chosen. It would be like taking names out of a really big hat. So that would give you a random sample. Now you might be thinking that, well, you might be wondering, what if some people don't consent, or simply refuse to participate, and you have some non-response? Well, if some people don't agree to participate, then the sample actually becomes not completely random. It becomes a little bit non-random, because when you have non-response, what you actually end up with is a non-random sample of a random sample. So when I randomly generate those student ID numbers, I get a random sample of ID numbers, right? But if some people if some people end up dropping out and not agreeing to take the survey, then what I actually end up with is a non-random piece of the random sample I started with. Well, the amount of bias that will happen depends on, well, it depends on a couple of things. It depends on how many people don't respond, how many people refuse to participate, and it also depends on if the non-responders are different than the responders. So the worst situation would be if a large number of people refuse to participate and those people are different than the people who did agree to participate, because then you're losing a big piece of your sample, and you're also losing a lot of one type of person. But there are strategies to try to minimize non-response, and we're not going to really get into those in our class, but non-response non-response is always an issue. When you do a survey study, you're bound to get at least some people not responding. So now let's talk about which one is better. Well, first of all, I wanted to mention that when I use the word random sampling in this class, I'm talking about the process of random sampling. So I'm not actually. So I mentioned how a random sample can actually turn out non-random if people don't respond. But when I say that something is a random sample, what I'm meaning is it was selected through random sampling, a random drawing, and it at least started out as a random sample before people dropped out. That's what I mean. I'm talking about the process of random sampling. So random sampling, especially large random samples, tend to be more representative than non-random samples. And that's because, so now we're talking about which sampling is better, and random sampling is more likely to give you a large random sample, especially if it's large, because random sampling gives all members of the population an equal chance of being chosen. And when you do that, you're likely to get a balanced mixture of people. Imagine this. Imagine you randomly generate 200 San Jose State student ID numbers, and you get a random sample of 200. You're not likely to get 200 of one type of person. You're not likely to get 200 18-year-old male freshmen by chance. You're more likely to get some of each grade level, some of each age group, some of each gender, and some of each type of major. You're likely to get a little bit of each type of person, and you're likely to get a pretty well-rounded representative sample, even if it's not perfect. So the reason why random samples tend to be more representative is because random sampling gives all population members an equal chance of being chosen. Now, a non-random sample can be representative if the researcher makes an effort to get a representative sample, but the representativeness of a non-random sample is always a judgment call that someone has to make. Whenever a non-random sample is selected, you have to put it under the microscope and look for different possible sources of bias. And you have to make a judgment call if the sample is any good. So if you hear that someone wanted to know the average height of the university, and you heard that the person went to an 18-year-old freshman class and surveyed 20 people, your judgment call would obviously be a bad sample. It's not representative. But if you heard that the researcher who did the non-random sampling made an effort to go out to different types of classes and to get different types of people, some of each major, some of each grade level, your judgment call would probably be, well, it's not random, but it's not terrible. It's probably a pretty good sample. And there are different types of non-random sampling. So we'll actually get into the types of random. We'll start with the types of random sampling, and then we'll go into the types of non-random sampling. So there's 3 types of random sampling that we'll cover: simple random, stratified random, and cluster sampling. We'll define each one, and then we'll talk about the purpose of each one. So simple random sampling is random sampling with one random drawing from a population. It's a one-step process. In simple random sampling, you take one random batch from the population, and you're done. So imagine I'm teaching a class, of 30 people, and I write each of their names on a hat, and I put the names into a hat, all 30, I shake it up, and I take out 10 names without looking. Those 10 will be a random sample of the 30. I'm sorry, those 10 will be a simple random sample of the 30 because it's just one random selection from all population members. Now imagine that I want to survey San Jose State students, and what I do is I go to a computer program and I randomly generate 100 student ID numbers. And I just take those 100 ID numbers and I contact the people. That would give me a simple random sample of 100 because I took one random selection of 100 from all of the university. So that's a one-step process. Stratified random sampling is actually a series of simple random samples. So stratified random sampling is random sampling from different subgroups of a population. So when I say a subgroup, I mean a specific category of population member. So let me give an example of stratified. So first let's go back to the classroom. Let's say I want to take a random sample of 10 people from a class of 30, and I know ahead of time that I want 5 males and 5 females in my sample of 10. Well, what I could do is get 2 hats, put the male names in one hat, put the female names in another hat, and shake up both hats, and then take 5 male names out of the first hat without looking, and take 5 female names out of the second hat without looking, put the 10 names together, and I would have a stratified random sample. And I would know for sure that my sample is going to be half male, half female. That would be stratified random sampling because I'm taking a series of random samples, each one from a different subgroup of a population. In this case, it's the first subgroup is male students, the second one is female. Another example might be, let's say that I want to take a random sample of 10 people from the class, and I know ahead of time that I want three sophomores, 2 juniors, and 5 seniors in my sample of 10. Well, I would just get 3 hats, right? I'm sorry. Let's imagine that my class has only those 3 grade levels. I would get 3 hats, put the freshmen in one hat, the sophomores in the other hat, and the juniors in the other hat, and I would shake up all 3 hats, and I would take out 3 from hat 1, 2 from hat 2, and 5 from hat 3, and I would get my stratified random sample. So I'm actually doing 3 simple random samples, and each one comes from a different category of population member. That's simple random sampling. That's stratified random sampling. So when people use, outside of psychology, when people use the word strata or stratified, they're talking about layers of rock. So in this case, the strata, the layers, are the different categories of population members. So it's kind of like, imagine that the class that I'm sampling has a layer of males and a layer of females, and I'm randomly sampling one layer at a time. Or imagine that a class, that each grade level is a different layer, and I'm sampling one level at a time, one layer at a time. That's stratified. Stratified random sampling is useful if you know exactly how many of each type of population member you want in your sample. Because when you take a simple random sample, you're not guaranteed to get the exact numbers you want, right? If you take a simple random sample of a class in one random drawing, you might get half male and half female, but you might not. You might get 6 males and 4 females, or you might get 8 males and 2 females, even though that's a little bit unlikely. But in simple random sampling, you're likely to get a pretty representative sample but you're not likely to get the exact numbers you're looking for. You just, because you get what you get, right? Now, cluster sampling is randomly selecting clusters of participants. So when you do cluster sampling, you're actually not taking a random sample of individuals, you're taking a random sample of clusters. And all clusters have an equal chance of being selected. So what's a cluster? Well, at a college campus, the classrooms would be different clusters, right? Because each classroom has a certain number of people in it. So if you randomly selected 10 classrooms on a campus, and you visited those 10 classrooms to survey people, those you would be doing cluster sampling, because the 10 classes that you selected would be your 10 selected clusters. So you're selecting 10 clusters out of all possible clusters, basically. The buildings on a college campus are also clusters. So imagine you wanted to take, imagine you wanted to give a survey out to San Jose State students, and what you did was you wrote the name of each building on a piece of paper. So you write Tower Hall on one piece of paper, you write DMH on another piece of paper, you put HGH on another piece of paper, Duncan Hall on another piece, then you put all of those names of the buildings in a hat. You shake it up and you take out, let's say, 3 buildings, and you then visit those 3 buildings to get participants. The 3 selected buildings would be your 3 selected clusters, and the hat that you took them from includes all possible clusters, which in this case are buildings. So let's say you end up drawing DMH, Tower Hall, HGH. You would visit those 3 buildings. That's cluster sampling. So in cluster sampling, each item that's being randomly selected is a cluster. So in cluster sampling, you randomly select a certain number of clusters. Students tend to have difficulty in understanding the difference between stratified random and cluster. So you have to remember, in stratified random sampling, you're randomly selecting individuals. It just happens to be that the individuals are being selected one category at a time. In cluster sampling, you're not randomly selecting individuals, you're randomly selecting clusters. So if you're doing cluster sampling and you're pulling pieces of paper out of a hat, the pieces of paper wouldn't be people anymore. They're not individuals, they're clusters. So you might be pulling buildings out of a hat, you might be pulling classrooms out of a hat, you might be pulling counties out of a hat. Like, let's say you draw Alameda County, Contra Costa County, Santa Clara County, and those are your clusters. That's cluster sampling. And the purpose of cluster sampling is to limit the number of locations that a researcher has to visit. So cluster sampling helps the researcher do things more conveniently. If you're needing to collect data in person, if you're needing to collect data in person, it can be very inconvenient to have to visit people who were randomly sampled over a very big area. So cluster sampling allows you to visit clusters rather than people who were just scattered all over the place. And I'll give an example of what I mean. So let's imagine that a researcher wants to interview high school teachers in the Bay Area. The researcher wants to get a sample of high school teachers and survey them. And the researcher doesn't want to have to visit too many schools because it'll be inconvenient to have to visit schools all over the Bay Area. And the researcher knows that if he or she takes a simple random sample of all Bay Area teachers, the researcher could get teachers in all over the place, from all over the Bay Area. So instead, the researcher puts the names of every school into a hat, shakes it up, and takes out the names of 5 schools without looking. And then the researcher visits the 5 selected schools. Well, that would be cluster sampling because the researcher is selecting 5 clusters out of all possible clusters, and the researcher won't have to visit that many locations because the researcher just has to go to the 5 schools that were chosen, the selected clusters. So cluster sampling can help tidy things up. It can help a researcher not have to visit too many different locations. And if the clusters that are selected are very large, the researcher can also the researcher doesn't have to collect data from every member of the clusters. Instead, the researcher could just take a sample of each selected cluster. So imagine that a researcher wants to interview people across the Bay Area, and the researcher randomly selects Alameda County, Contra Costa County, and Santa Clara County as the 3 selected clusters. Well, the researcher obviously isn't going to interview everyone in all 3 counties because it's too many people. So what the researcher would do is take a simple random sample of each of the 3 selected clusters. So if the 3 selected counties are Alameda, Contra Costa, and Santa Clara, like I said, the researcher could go one step further and take a simple random sample of Santa Clara, a simple random sample of Alameda, and a simple random sample of Contra Costa. So that would actually be cluster sampling followed by a simple random sample of each selected cluster. That can be done by a researcher. If the clusters are too big to take everyone from every cluster. Now, if the clusters were, let's say, classrooms, the researcher could probably just take everyone from each selected class and take the clusters in their entirety. So here's a diagram. So here's that I created. Here's simple random sampling, just names out of a hat. Here's stratified random sampling, maybe 3 hats and 2 from each. Here's cluster sampling where a researcher actually has 3 groups and the researcher selected 2 out of the 3 randomly. So imagine that there's another hat over here with 3 pieces of paper in it, and the papers are 1, 2, and 3, and the researcher happens to take 1 and 2 out of the hat, and that's what gives the researcher group 1 and group 2. That's cluster sampling. So now we've talked about the types of random sampling and their purposes. Now let's talk about a few types of non-random sampling. The first one is convenience. So convenient sampling is just selecting participants in the most convenient way possible. It's whatever is convenient for the researcher. So if a researcher let's say a researcher is a professor who's teaching a class, and the researcher just surveys his or her students in the classroom, that's convenience because it's convenient for the researcher. Quota sampling is convenient sampling, but with targeted numbers of different types of people. And these targeted numbers are called quotas. So if a researcher does if a researcher does convenient sampling, but does it while ensuring that to get a certain number of each type of person, that's quota sampling. So let's now imagine that a researcher is a professor who's teaching a class, and the researcher wants to survey. Well, the researcher knows that his or her students are a convenient way to get participants. So the researcher just goes to his or her students to get participants, but the researcher ensures to walk up to 5 males and 5 females in the class. That's quota sampling. Or let's now imagine that a research method student wants to get a sample, and the student knows that he or she wants to get 5 males and 5 females. So the researcher just goes to the student union and walks up to the first 5 males that he or she sees and walks up to the first 5 females